for any kind of expression. So for that, there are multiple operators are there. So basically we have two kind of operators, either binary operator or a unary operator. So for unary operator, only one variable will be sufficient. For binary operator, we will require at least two variables. Okay, and this function can be described with the help of a truth table. So basically this algebra compromises of set of element, means those variables or literals, then binary operators or unary operators. Binary operators, as we discussed, it can be plus or dot, and or, and unary operator is your complement. So with the help of that, we can go for any kind of expression. So one expression can be, suppose, a dot b plus a bar dot c. F can be a plus b dot a plus b bar plus c. F can be a complement only. So any kind of expressions are possible. Okay. So with the help of this operators, you can go for any kind of expression. So in this Boolean algebra, we will have certain axioms and laws that we have to follow. We already discussed these things, just to overview. So in Boolean algebra, if we go for 0.0, this will be 0. 0.1 will be 0. 1.0 will be 0. 1.1 will be equal to 1. Okay. Similarly, your 0 plus 0 will be 0. 0 plus 1, they are logical operations. So 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. Okay. So basically this is nothing but the AND operation. This is nothing but the OR operation that we discussed in the previous class. So basically these laws are followed. Similarly, if I will go for zero's complement, what will be zero's complement? If we will take complement of 0, what will get?
One.
Zero's complement must be 1. Similarly, 1's complement must be 0. Now suppose I have a variable a which is equal to 0. So what will happen? A bar will be equal to 1. If a is 1, its complement will be equal to 0. Now think about AND operation. Now suppose in AND operation, what I am doing, I am going for a dot 0. So a is variable, it can take two values, it can take 0 or 1. But second input is fixed, which is 0. So these two possibilities are there. What will happen to this? 0.0 will be how much? 0.0?
Zero.
0. 1.0 be also 0. So what can we comment from this? It will be a dot 0. कितना होगा a dot 0? A dot 0 will be 0. Okay. Similarly, next a dot 1, a can be 0 or a can be 1. So 0.1 is 0. 1.1 is 1. So what happens? Basically, whatever is the value of a, same thing we are getting in the result. So a dot 1 is a. Next, if we'll go for a dot a can take two values. A can take 0 or a can take 1. What will be 0.0?
Zero.
0. 1.1, 1. So whatever is the value of a, same thing we are getting. So a dot a is a. Next, a dot a bar. If a will be 0, what will be a complement? A complement will be 1. If a will be 1, what will be a complement? It will be 0. So how much will be 0.1? 0.
Zero.
1.0 is 0. So irrespective of value of a, output should be 0. So a dot a bar is 0. Next, a plus 0. Next is a plus 0. So a can 0, a can be 1. What will be 0 plus 0? 0. 1 plus 0? 1. So how much will be a plus 0? It should be same as a. Whatever is the value of a, same thing we are getting in the result. So a plus 0 will be equal to a only. Next, a plus 1, a can be 0 or a can be 1. 0 plus 1 is 1, 1 plus 1 is 1. So whatever may be the value of a, result is always equal to 1 only. Next, a plus a, 0 plus 0 or 1 plus 1. How much will be 0 plus 0?
Zero.
1 plus 1 is 1. So whatever is the value of a, same thing you are getting in the result. So a plus a is equal to a. Last, a plus a bar, how much? If a is 0, a bar is 1. So 0 plus 1 is 1. If a is 1, a bar is 0. So 1 plus 0 is also 1. So what happens? A plus a bar is equal to 1, irrespective of value of a. So a plus a bar is equal to 1. So now, as we understood this, whenever these expressions come, directly we can write these values. Okay. Next is duality. So if a function is given, a boolean function is given. Suppose boolean function is given as ab plus b bar dot c. Okay. So whenever we have a boolean function, so its dual function also exists. What is its dual function? We can get dual function by exchanging dot with plus, plus with dot, 1 with 0, 0 with 1. So by interchanging this, we'll be able to get a dual function. So what will be dual function of this f? F will be equal to a, dot will be changed to plus, this will become a plus b, this plus will become dot, this will become b bar plus c. So this is the dual function of f. So this dual function will be useful to find the complement. To find the complement, this dual function is used. Also, we'll see later on in the next slide, whenever we'll prove something, if a function is true, its dual is also by default true. So if function is correct, its dual function will be also correct. Like if I'll say that, if I'll write a plus a bar b plus 0 is equal to a plus b. Okay, we'll prove that later on. But this is the function now. So what will be its dual function? Just we need to replace this plus with dot, dot with plus, 1 with 0, 0 with 1. So a will be as usual plus change with dot, then a bar dot is replaced with plus, plus with replaced with dot, 0 is replaced with 1. This will be equal to, this plus will be replaced with dot. So a dot b. So if this function is correct, then this is also correct. If something is proved, its dual is also proved. Okay. If function is correct, its dual is also.
Can you explain this dual function once again?
Dual function we can only find out by just interchanging this much. Dot needs to be replaced with plus, plus needs to be replaced with dot, 1 with 0, 0 with 1. So by interchanging this, we'll be able to get the dual function. So this example, just we can see by just replacing dot with plus, and here plus with dot, here dot with plus. So whatever function we are getting, that is called as a dual function. Is it clear? Just we need to
Yes, sir, clear.
replace this much only. Now, next is De Morgan's theorem. So, De Morgan's theorem is used to find the complement. So, as per this De Morgan's theorem, what happens? One second. Your a plus b whole bar is equal to a bar dot b bar. Okay. Similarly, A dot B whole bar is equal to A bar plus B bar. Okay, so basically how to get this? So whenever a function is first of all given, to find its complement, you need to find the dual function. After finding the dual function, in dual function what you need to do, whatever variables are there, you need to complement it. If you complement it, you will find the complement of the f. Okay. So to find the complement of any function, first you need to find the dual function like this, a plus b. What is the dual of a plus b?
A dot B.
So dual will be a dot b. Then to find its complement, a needs to be replaced with a bar, b needs to be replaced with b bar. Okay, whatever variables will be there, it need to be replaced with its complement. Okay, so in this way we can find out first the function, then the dual function, then in dual function if we replace it with its complement, all variables complement, will get the complement. Okay, so here example is given. One second. So either you can follow this step or you can directly apply De Morgan's theorem also. From that also you'll be able to find out the complement. So let us see. So function is given as a plus b dot a bar plus c. Okay. We want to find its complement. To find its complement, what to do? This is given. Okay. So this function is in the form of x dot y whole bar. This is x, this is y. Then this is in the form of x dot y whole bar. So what is De Morgan's theorem? X dot y whole bar is x bar plus y bar. So what is x here? X is a plus b. So its complement plus. What is y here? Y is a bar plus z. Its complement. Okay. Now next step, we can apply De Morgan's theorem. This also, a plus b whole bar. What is a plus b whole bar? A plus b का whole bar कितना होगा? How much is a plus b whole bar?
A bar dot B bar.
A bar dot b bar
Yes, sir.
plus. Now this is your x, this is your y. So it is in the form of x plus y whole bar. So x plus y whole bar is how much? X bar dot y bar. So what will be x bar? It will be a
X.
A
double
dot B.
complement dot c complement. But double complements cancel each other. Okay. So what will happen? This will be a bar dot b bar plus a dot c bar. Okay. So you can, we followed like this, or we can also directly convert this into a dual function. From that also we'll be able to find out what will be dual of this function. Dual क्या होगा?
A plus B
नहीं
plus
प्लस
A
नहीं
bar
होगा,
A
plus
bar
प्लस नहीं.
plus B bar.
No, 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 no. Dual is not that. Dual is only plus needs to be replaced with dot. Dot needs to be replaced with plus. One with zero, zero with one. So dual will be how much? A dot B
A dot B plus
plus
A bar
A bar
dot C.
dot C. Then to find the complement, each variable needs to be replaced with its complement. So A will be A bar, B will be B bar, A bar will be A double bar dot C bar, which is A bar dot B bar plus A dot C bar. In this way also you'll be directly able to find out. Whatever we're following, basically we are going through this step only. First we need to find the dual, then we need to replace each variable with its complement, then we'll be able to get the complement. Okay, so simple steps. Up to this, any doubt, anyone? Any doubt up to this? कुछ डाउट है यहाँ तक? Anyone?
No, sir.
One second. One second. Hello. हम मैं क्लास चलची क्लास रे हाँ okay so up to this much any doubt anyone up to this any doubt anyone
No,
No,
sir.
sir.
so next we will deal with laws and theorem okay so this one we already discussed. This name is called as identity law. So as for this, x plus 0. What will be x plus 0? We already done this. A plus 0. क्या होगा? X plus 0 क्या होगा?
X.
This will be x. X can be 0 or 1. We know that 0 plus 0 is 0. 1 plus 0 is 1. So whatever is the value of x, same thing we are getting. So x plus 0 is x. So whenever we'll come across this, we do not have to solve this. We can directly write if x plus 0 will be there, we can directly write that x plus 0 is equal to x. This is the identity law. So its dual is also correct. What will be dual? To write dual, just plus needs to be replaced with dot, 0 needs to be replaced with 1. So x dot 1 will be equal to x. Next. Next law is called as non-law. As per this, x plus 1 will be equal to x. Sorry, x plus 1 is equal to 1. So x can be 0, x can be 1. 0 plus 1 is also 1, 1 plus 1 is also 1. So irrespective of value of x plus 1 is always equal to 1. Okay. So x plus 1 is 1. What if it's dual? Plus needs to be replaced with 0, 1 needs to be replaced with 0. So x dot 0 is equal to 0. This is called as null law. Next one, idempotent. As per this, x plus x is equal to x. As we discussed, 0 plus 0 is 0. 1 plus 1 is 1. So whatever is the value of x here, same thing we are getting in the output. Okay. So x plus x is equal to x. That means if you add two same input, then if you logically add two same input, then output will be that variable only. What will be its dual? Dual will be x dot x equal to x. Next law. Next law is called as involution. Involution. That means x double complement is equal to x. Next law is called as complementary. So as per complementary, what happens? X plus x bar is equal to 1. So if x is 0, x bar will be 1. If x will be 1, x bar will be 0. What will be 0 plus 1? 0 plus 1 will be 1. 1 plus 0 will be 1. So whatever may be the value of x bar, your result will be always 1. So as per complementary, x plus x bar is equal to 1. Similarly, it's dual. What will be dual of this? Just we can replace plus with dot 1 with 0. So x dot x bar is also equal to 0. No need to prove it. Once this is proved, its dual is also correct. Next, commutative. What do you mean by commutative? Anyone? Commutative law? Commutative क्या है? Commutative means what? Just
A plus
answer.
B equal to B plus A.
A plus B is equal to B plus A. So in our domain, what do you mean by this? Means that A plus B means what? This is nothing but a OR gate. So AB is equal to A plus B. So B plus A means what? This is B, this is A. So both these results are same. So wherever you want, you can put that input, but result will remain same. So its dual will be x dot y will be y dot x. Okay. X dot y means what? This is a AND gate. This is X. This is Y. This will be X dot Y. So this will be same as Y dot X. Okay. Next, associative. What do you mean by associative? Associative क्या है? The standard one mathematics.
A,
Associative.
A plus B plus C
A
equal
plus
to
B
C
plus
plus
C. A plus B plus C is equal to A plus B plus C. That means what? A plus B plus C is equal to A plus B plus C. Okay. That means what? If I'll go for a OR gate, this is A, this is B. So what will be output? Output will be A plus B. Then I want this result with C. So this will be A plus B plus C. So this is same as this A plus B plus C. That means what? B plus C means what? This OR gate's input will be BC. थोड़ा उल्टा हो गया. Then if this is A, this will be A plus B plus C. Both are correct. So A plus B plus C is same as A plus B plus C. So its dual is also correct. Its dual will be x dot y dot z is equal to x dot y dot z. Just need to replace plus with dot and dot with plus because 1 0 is not there. Okay. Next one, distributive. What do you mean by distributive? Distributive क्या है? Anyone? Distributive.
A into B plus C
A into
equal
B
to
plus C is equal to A
A
dot
into
B,
B plus A into
A
C.
dot into C. So A dot of B plus C is equal to A dot B plus A dot C. So in our digital domain, what do you mean by this? B plus C क्या है? This is a OR gate. Then A dot means this is a AND gate. So it is A dot B plus C. This is same as A dot B. A dot B means this is A, this is B. A dot C means another AND gate. Same A, C. Then A OR gate, which will be equal to A dot B plus A dot C. Okay, this is called as a distributive. So once it is proved, its dual is also proved. What is the dual of this? Dual we can obtain just by replacing dot with plus and plus with dot. Okay. So A plus BC will be equal to A plus B dot A plus C. Okay. So up to this much you already know. You are already knew about up to this distributive. Okay. This is clear to you. Because these are the basic mathematics also we are coming across these laws only. Next is uniting. So in uniting what happens? A dot B plus A dot B bar. Okay. If it is A dot B plus A dot B bar, what can we do? I can take what? क्या कर सकते हैं? We can apply distributive. We can apply distributive. So what can we write here? As per distributive, what can we write? This is same
A
as the
dot
RHS. So we can write A dot of B plus B bar. Again, what do you mean by B plus B bar? This is complementarity. This is the complementary law. What is it? It is A dot 1. B plus B bar is equal to 1. What is A dot 1? This is identity law. What is identity law? Ki x dot 1 is equal to x. So A dot 1 will be A. So whenever we'll come across this A dot B plus A dot B bar, we can directly write this as A. You do not have to follow these steps. You can directly write this as A. So its dual is also correct. Next one. Absorption law. Absorption law. So x plus,
Sir,
yes.
can you go to the previous slide for 1 second? Okay, now. Thank you. Yeah.
Okay. Next, x plus x dot y. Okay, x plus x dot y. So I can take x common here. If I take x common, this will become x dot 1 plus y. What will be 1 plus y? How much will be 1 plus y? 1 plus y कितना होगा? 1 plus any variable, if you add something with 1, what will be the result?
So one.
So one.
1 only. So this will be x dot 1. So x dot 1 is what? X. So
X.
this is called as absorption law. X plus x dot y will be same as x. Similarly, dual is also correct. How to get dual? X dot x plus y will be equal to x. I just replace plus with dot and dot with plus. So these are straightforward. In 1 2 steps, we'll be able to get it. Next is redundant literal rule. So as per this, your x plus x bar dot y will be equal to x plus y. Okay. So again, it is in the form of distributive only. We know that. What is a plus b dot c? As per distributive, this is same as a plus b dot a plus c. So if we'll apply same law here distributive, what can we write? X plus x bar y. क्या लिख सकते हैं? X plus x bar y. What can we write? अरे a क्या है यहाँ पे? What is a here?
Plus
X.
x dashed dot
B is x bar, C is y. So just compare it. It will be x plus x bar dot x plus y. What is x plus x bar? X plus x bar is always equal to 1. So 1 dot x plus y. If you add something with its complement, only two things are possible. If x is 0, then only output is 1. If x is 1, then only output is 1 only, because x plus complement is there. So 1 dot x plus y will be equal to same as x plus y. Okay. So this is called as redundant literal rule. Last one. Last one, consensus is very means it is little bit tricky and easy and important. Out of all this, maybe if you don't remember also, in 1 or 2 steps you'll be able to get it. So out of all this is the important one, consensus. So as per this, what will happen? X dot y plus x bar dot z plus y dot z. Okay. Now you observe this first term, second term, and third term. So first term, which variables are there? X is there, y is there. Second term, what is there? X bar is there, z is there. Okay. That means what? That means in the first term, x is present. Second term, x bar is present. Apart from this, what else is present in those two terms? Y is there, z is there. So in the third term, those things were multiplied. So y and z were multiplied. So as per consensus theorem, what will happen? We can neglect this y and z. So this will be equal to x dot y plus x bar dot z. Xy plus x bar z plus yz is equal to xy plus x bar dot z. Is it clear? First of all,
Sir,
this rule is clear. Then we'll go for proof.
no, sir. Can you explain this once more, sir?
Now suppose I will write a here. In second term I am writing a bar. Okay. So whatever variable is present here, same its complement is present in the second term. Apart from this, suppose here we have x, here we have y. So third term, what happens? These remaining variables are present. This multiplication of those variables are present. If that is the case, then it can be removed. So it will be same as a dot x plus a bar dot y. Okay, so either we can remove this, or if we have, then we can add this also, depending upon our requirement. Okay, so is it clear? First of all, then we'll
Yes,
go
sir.
for proof. Okay, now let us prove this. Okay, now can I write like this: x dot y plus x bar dot z plus, in place of yz, can I write like this: 1 dot y dot z? Will it be okay? Is it okay? Because we know that a dot 1, how much is a dot
Yes, sir.
1? A dot 1 is a
8.
only. So in place of yz, I can write like that: yz dot 1. Now, in place of 1, can I write like this: 1 is a plus a complement. A plus a complement is equal to 1. So what I will do in the next step, I will write with respect to x. So I can write this as x plus x bar dot y dot z. Then if I apply distributive, if I'll open this bracket, what can I write? I can write that xy plus x bar dot z plus, if I'll open this, what I can write? X dot y dot z plus x bar dot y dot z. Now observe first term and third term. Can I take anything common?
X1.
Xy, first and third. Xy, so what will remain? 1 plus z. Similarly, second and fourth term. Can I take something common? X bar dot z. What can we write? X bar dot z क्या होगा? 1
1
plus.
plus 1.
Now we know that 1 plus z is how much? 1. Here also 1 plus y is 1. xy dot 1 is nothing but x dot y z है ये. So here x bar dot z dot 1 is nothing but x bar dot z. So LHS is equal to RHS. Okay. So depending upon our requirement, if we want, either we can remove this, or if you want, we can add this also. Okay, that will depend upon our requirement. As per the consensus theorem, we can remove one term and we can add one term if this is the case. Okay, so this is a very useful theorem. The next theorem is just a extension of this consensus only. Okay, so can you prove that? Just open that bracket, nothing else. So x plus y dot x bar plus z. One second. So as per transposition, x plus y dot x bar plus z. Okay. If I'll open this bracket, what can I write? If we'll multiply this two, what we can write?
X bracket x bar plus z plus y.
एक साथ लिख देते हैं. This will become x dot x bar plus x dot z plus y dot x bar plus y dot z. Okay. So what will be x dot x bar? What will be x dot x bar?
0.
0. If you add something with 0, result will be remaining terms only. So no need to write this. Now remaining what we have? We have x dot z plus x bar dot y plus y dot z. Now observe, this variable is present here, its complement is present here. What is remaining terms? Z and y. This is multiplied. So as per consensus, what we can do? We can remove this term. So what will be result? Result will be x dot z plus x bar dot y. Okay, same thing is mentioned here. This is called as transposition. Okay, so why we are learning all this? Why we are learning all this? Okay, so whenever we are implementing any expression, okay, suppose I want to implement this function a b plus B bar. Okay, let me not take complement. AB plus BC plus AC. If I want to implement this function, what are the different gates will be required? What are the different gates will be required to implement this?
Or and.
Or and AND. So basically, I will require how many AND gates? How many AND gates will be required?
Two and three or
No, three
three
AND.
and two or
No, acha, three AND gates. A B B C A C. So here I will get A B. Here I will get B C. Here I will get AC. Then this needs to be added. Now suppose I have a three input OR gate available. One, two, three. So just I need to connect them, nothing else. So here I will get the function. Okay. So whatever expressions are given, we need to implement. Okay. So basically, what is happening? We're requiring certain gates. Okay. So your cost of your design will be directly proportional to the number of gates. Suppose more number of gates are required, then more costlier will be the circuit. And also it is not only depends upon gate, it also depend upon the number of inputs to the gate. So it is not similar that I will suppose use, here I am using how many inputs? Input 1, input 2, input 3, input 4. How many gates I used? I used two
two.
gates. Now suppose in place of that I have a 5 input gate is available. Okay. So here I am only using one gate, one logic gate. But how many inputs are there? 5 inputs are there, whereas here 4 are there. So it will be better as compared to this. Okay. So your cost is directly proportional to the number of gates and also to the number of input. More inputs are used, more logic gates inputs are used, then more costlier will be the circuit. So what we need to do, will always try to reduce the expression. Whatever Boolean functions were given, we'll try to reduce the expression. So if we'll be somehow will be able to reduce the expression, then less cost will be required to implement the circuit. Okay. So whatever theorems we studied, by help of that, it will be able to reduce the expression better. Okay. So let us go through an example. See this example. X is taken as this j function z is given as this. Now to implement this, how many gates will be required? फर्स्ट देख लेते हैं कितना चाहिए, यहाँ पे कितना गेट चाहिए होगा. How many AND gates will be required? कितना गेट्स चाहिए होगा AND gate? How many?
Seven.
9 नहीं, AND चाहिए. This is a AND gate, this is a
Five.
AND, this is a 5 AND gates. Means 3. How many input? 3 input AND gate. 1 OR gate, 5 input. Apart from this, I also require NOT gate. A bar is required, B bar, C bar is required. So 3 NOT gates are required. Okay. So we'll see, can we reduce this or not? Okay. Now, observe this.
How many not gates?
not gate.
Sir,
A bar, B bar, C bar.
फाइव नॉट
नहीं, A बार चाहिए ना, A बार चाहिए, B बार चाहिए, C बार चाहिए, करे ना.
तो वही सिग्नल फिर से यूज कर
हाँ, same thing ना. Suppose A is available, we'll take to different gates ना. Same is taken to different way.
ओके
So it is not that A is available twice. A is the same variable na, same input. So suppose
सर गॉट
here A is used. Okay, so same needs to be connected. Now observe this second term and third term. I can take A B bar common. Then this will be C bar plus C. Similarly, fourth and fifth term, I can take AB common. Again, C bar plus C. What will be C plus C bar? C plus C bar 1. So this will be AB dot 1. This will be AB bar dot 1. So how much will be AB dot 1? AB dot 1 is same as AB. AB bar dot 1 is same as AB bar. Next, out of these two, I can take A common. So this will be A into B plus B bar. Again, B plus B bar is 1. So this will be A dot 1. How much is A dot 1? A dot 1 is A. So
G.
now I
A,
have
yes, sir.
A plus A bar dot BC. Okay. So check this law we discussed. X plus, we proved that x plus x bar y is how much? Redundant literal rule कितना हुआ था? X plus y here, x plus x bar y is same as x plus y. So here, if we compare, who is x? X is A. So x bar is how much? A bar. What will be y? Y will be B dot C. So कितना हो जाएगा? This will be x plus y. X plus y means what? A plus B dot C. Now you can observe, now this function, instead of this complicated expression, it is reduced to A plus B dot C. A plus B dot C. Okay. So to implement this, what are the different gates required? I will require an AND gate. I will require a OR gate. I'll get Z here. So it is same as implementing this. So our cost is getting reduced and it will also require less space. Okay. So whenever we'll go for any implementation, our objective should be to always to reduce the expression. We should always reduce the expression so that less number of components will be required and cost will be less. Similarly, check this example. Okay, try to solve this. So function is given as this: a plus bc whole complement multiply with ab complement plus abc complement. Okay, so let us first apply De Morgan's theorem to this. What will happen? As per De Morgan's theorem, it will be a bar dot bc whole bar dot. Here, if I will take a common, I can write b bar plus b dot c. Next step, I can write a bar dot bc double complement is how much? BC double complement
BC.
BC.
BC dot A.
BC.
What is B bar plus BC? It is in the form of x plus x bar dot y. So as per redundant literal rule, we know that this is equal to x plus y. So if we compare this, what is x? X is B bar. What is x bar? It is B double complement, which is B. What is y? Y is C. So if we apply redundant literal rule, what can we write? This will be equal to how much? क्या होगा?
B bar plus C.
B bar plus C. So all are multiplied. So we have A bar dot A. So anyway, this will be equal to 0. Okay. Okay. Let us stop here. We'll be not able to finish this. So we'll do that in the next class. Okay.
Sir, in this it will be one AND gate and one NOR gate. No?
Where? In this question? Nothing required. Na, direct 0 is given. So function is direct equal to 0 here.
No, sir. If up to means B bar plus C if it is taken then.
Then you will require NOR gates. You will require. Okay.
And
So
OR
everyone,
gate. NOR and OR.
NOR gate require, AND gate require, OR gates are required. Okay. So everyone, write your roll number in the chat box. Those who have written, they can leave. I have already uploaded this notes. This PPT is already uploaded. You go through that. Okay. If any doubt, ask me in the next class.